We were just saying that we're going to be needing highly purified silica to make this glass, and we'll talk about why here in a minute. But so we had said that you could use charcoal, the carbon, to combine with the oxygen to strip off some of the oxygen, and then further purify the silicon by a treatment with an acid. And we ended up with that 99 point with all those nines on the end, either a 9N or 12N purity. Now, so how do we make glass? So you take this silicon dioxide, this very pure silicon and silicon dioxide, and what you do is you heat it up. So you melt the glass, or you melt this sand material basically, and then you cool it very rapidly. And so if it was to cool slowly, you would form a crystal, like a quartz crystal has the same chemistry as glass. But it's not very useful because it's kind of a, you'd have to have a weird looking window if you had quartz crystals there, and it would be transparent, but it would still be hard to see through. So what you do is you take glass and you cool it very rapidly, and rather than forming a crystal, it forms what we call an amorphous solid. And that means that all of the atoms are there, but they're not highly organized. But what's good is you can see through them. Now, we all know with these phones, if you just barely tap the glass or you drop it, it's going to shatter, right? No, it doesn't, does it? And yet, most glass does, right? So most glass, if you hit it wrong, or, God forbid, how many times you've dropped your cell phone, and once in a blue moon, it does break. But for the most part, pretty tough glass. Now, how do they make glass do that? And what they do is they take this highly purified substance, and then they add tiny amounts of something else. And your book talks about Pyrex. You may have heard of it. It's like a cookware. And it has, what is it, boron, and I forget what else. It's got a few things. Silicon, yeah, it has small amounts of boron and sodium added to it. And this makes it strong. Now, some of you might even know this. You might know the name of the glass that is used on cell phones. It's called Gorilla Glass. And so if you take that Pyrex or glass that has some sodium in it, and you replace that sodium with potassium, you end up producing something called Gorilla Glass. And in theory, it is incredibly strong. Its strength is strong enough to withstand 10 gigapascals. Let me make sure I'm telling you the correct number. 10 gigapascals. And what, I'm sure you all know what that is, right? No. It's a lot. It's the equivalent, believe it or not, they say, of 100,000 elephants standing on the glass. Pretty darn strong. Now, we all know it actually does break on occasion, so that's the 100,001, or, somehow. But it's really, really strong. So what they do is they produce this amorphous structure, and with a few added extra chemicals in there, elements in there. In the case of the Gorilla Glass, it has potassium in there instead of some of those sodium ions that we had said, like when you made Pyrex, which is another version of a strong glass. Now, when we talk about other kinds of glass, we had said that there is crystal silicon dioxide crystals, and we had said quartz, and there's another one that is also chemically very similar, and it's, amethyst. Let me double check to make sure I'm telling you correctly. It's amethyst, I'm sure. Yeah, it's amethyst. And you might know that there is even some applications where what they do is in the laboratory, they grow these giant amethyst crystals, and it takes weeks. So it's a really hard, long process. But this is, in terms of hardness and strength, it's second only to diamonds. So it's incredibly strong, and it's what they use in an airplane window, or also apparently the scanners when you bring your groceries, because they're constantly having cans of peas or whatever put on top of them to make them strong and not scratched up. They use this amethyst type glass. Okay.